Hi there, I'm Mitch Randall, and I'm the Technical Manager for KEB UK, and I'd like to show you in this short video the blockage detection functionality of the Generation 6 hardware. This blockage detection, which is commonly referred to as locked rotor detection by some people, is a useful function that's built into our KEB drives. It's been in the F5s for a number of years, and we've now brought the same functionality into the Generation 6 hardware. For the purpose of this video demonstration, we've dragged in one of our motor generator rigs from our test area, and this rig consists of two motors that are close coupled together. The motors are asynchronous, they're both 2 kilowatts. The one on the right hand side is basically a closed loop motor with encoder feedback giving us 150% torque. And the test motor, which is coupled to our F6K drive here, which is a 4 kilowatt drive with the latest blockage detection firmware in, that has been wired in and has got no encoder connected. So it's set up and running in what we call Ascl mode. This Ascl mode is asynchronous sensorless closed loop control. To give us the best performance for closed loop accuracy without any feedback device. The only extra component we've actually added to this entire rig here is this delay off timer. The purpose of this delay off timer is to give us a reverse signal for 5 seconds once the blockage has been detected. In this way we can clear the blockage and then force the drive to go back into a processing operation in the forward direction. For the purpose of this demo, I've looked up my laptop to the F6. The laptop's going to record a scope trace, and on the scope trace we're going to have the blockage detection status, the apparent current, the actual torque output from the drive, and the motor speed. So hopefully afterwards we can actually have a quick tour through this scope plot and show you exactly what's been happening on this rig, because it does happen ever so quickly. It's a very quick demonstration. Right, to start this demo I'm going to get my scope trace running here with the CombiVis 6, and now I'm going to enable the F6. It will run up to 1500 RPM in the forward direction. Now I'll apply a holding or a stall torque to it, and takes it, runs off in the opposite direction, brakes away, take the load off, there it goes, and stop. Now let me talk you through the scope trace that we've recorded during this test here. So starting with this cursor here at the beginning, we're not moving. The red trace line is the actual speed in RPM, and this is the point at which I enable it. It ramps up ever so quickly into the forward direction, running at 1500 RPM. As you see, the load is negligible because we haven't applied any, and it's running along quite happily here with about 5 amps of current, 1500 RPM, nicely controlled shaft performance here. And we get along to the point where I enable the motor generator part. So I switch the motor generator on with the stall torque. We stall the motor here, and as you see, the blockage detection timer starts running. This is a timer that we can set inside the drive. For the purposes of this demo, it's been set to 1 second. So it's sitting there holding the full torque at 150%, stalled. You see the red line's gone down to 0. After a second, it then goes into the reaction timer, or the reaction response. Again, for the purpose of this demo, we've set it to 1 second, this timer inside the F6. And at the reaction timer, it starts to ramp the torque down, and when it reaches a low level here, of about 5 amps or 4.8 amps there. It then says the blockage has been reached, the alarm's set. The alarm bit then triggers the digital output, which triggers the relay, the delay off relay, which is set for 5 seconds. This relay then sets the drive running in reverse, the reverse input on the drive to clear the blockage, and the ramp down of the speed set point into the opposite direction. As soon as it goes past the 0 point, it takes off in full speed in the reverse direction, reaching 1500 RPM in reverse. Bear in mind we still have the load attached. Yeah, it gets 150%, breaks away, and then the as it levels off, it starts to drop to 126%, still at full speed. And here we go. At this point here, we basically switch the load off the motor generator, and it's running at full speed with no load. The blockage has been cleared, going all the way along. I'll just go to the next part. Yeah, and after about 5 seconds on this delay off timer, we switch back to forward running. So we start the shredder in the forward direction again, and it changes direction, goes past 0 point and ramps up quickly into the forward direction, and away we go again, starting to go into production, waiting for the load to come on again and shredding the material. So to sum up this video demo here, we showed the blockage detection, and this blockage detection, or locked rotor detection as some people like to call it, lends itself to quite a few different applications. The demo here is mainly sort of shredder based, but can also be easily transposed onto extruders where you haven't got the melt temperature up right and the screws being locked, or even a compressor with a locked rotor for some reason or other. It lends itself to protecting the motors from being cooked and destroyed by excessive current, as well as protecting the mechanics from damage from high torques from powerful motors. So if you have any questions regarding this demo, or you've got any particular interest in wanting to know a bit more about this blockage detection or locked rotor detection and how it can be implemented in your own applications, please feel free to contact us at info@keb.co.uk, and we'll be happy to get back to you and even show you the practical demonstration of it.